Now, you don't have to be a medical doctor or a PhD student in wood science to know that a table saw is really kind of an innately dangerous thing. It is easily one of, if not the most versatile and useful tools in most workshops. But it ultimately is a large, rapidly spinning blade that you feed wood through. There are all sorts of ways that this can cause severe injury, from kickback to getting your hand caught in the blade, etc. Table saws can be used safely, but you have to educate yourself in the potential ways they can go wrong. You can go right now and search table saw kickback and find all sorts of videos on YouTube and other places documenting the risks and ways to prevent kickback. And a table saw is meant to cut large volumes of lumber quickly. If a saw can cut through, if it has the power to cut through 3 inches of solid oak without breaking a sweat, it will go through your fingers, hand, or your entire arm before your brain can even process what is happening. A severe injury on a table saw can occur literally faster than thought itself. A table saw is not a hot stove. It's, like a hot stove, you can touch the surface of the hot stove, and your brain can react fast enough to start feeling the temperature, start feeling the heat, start feeling the pain, and withdraw your hand back before you get any kind of serious injury. But that does not work with large, very rapidly spinning blades like you have in a table saw. You can't touch the blade, feel pain, and pull your hand back before serious damage is done. It's just not possible. Before your brain can even start to process what is happening, your fingers will be gone. So make no mistake, table saws really are a potential safety risk. Much care needs to be taken to use proper blade guards. You need to understand how kickback works and how pieces can bind on the blade and between the blade and the fence. You need to know how to align your table saw's fence to prevent binding. You need to know how and what directions to apply pressure to wood as you feed it through a saw in order to prevent it from becoming a safety hazard. You need to know how to use blade guards, splitters, riving knives, and how to safely perform cuts in cases you can't use in cases and cuts where you can't use your saw's blade guards. And there are some cases, some particular difficult cuts, where you simply can't perform the cut while leaving the blade guard on. And above all else, regardless of how experienced you are with a saw, you need to respect it. There are plenty of woodworkers and professional carpenters who've been, working with a table saw for 30 years and have never had a serious injury, and then they lose several fingers on their first day of their 30th year of woodworking. So above all, you need to respect these tools. It is a tool that can seriously hurt you, and you have to be able to respect that power. I certainly respect mine. I currently have all my fingers, and I intend to keep it that way. Now, the safety techniques I mentioned are true of all saws, even those made a century or more ago. So things like, aligning the fence, things like blade guards, that kind of thing. Applying pressure to pieces of wood as you're pushing them through the blade. All of these things are universal to almost all table saws. You could use them as on a saw made today or a saw made 100 years ago. But considering the risks involved, it's no surprise that a lot of brilliant people over the years have put their minds to work trying to improve the safety of table saws. Often they've tried to harness the power of modern computers and electronics technology to make a saw safer. But really, it is a hard problem. Again, these are injuries that occur quite literally faster than the blink of an eye. My saw, for example, will spin a 10-inch diameter blade at approximately 4,000 RPM. And if you do some quick math, you'll find that 4,000 RPM is 419 radians per second, and at 419 radians per second, a 4,000 RPM 10-inch diameter blade has its teeth traveling at 175 feet per second, 53 meters per second, 192 kilometers per hour, or 119 miles per hour. So, if you want to get a sense of the kind of reaction times and energies and forces involved, imagine a typical passenger car. Imagine just like a car you might own or see going down the highway, whatever. Not something like a fancy sports car or like a racing car or anything like that. Just a regular passenger car or an SUV or whatnot. They typically have governors that kick in somewhere in the range of 110 to 130 miles an hour, something like that. So imagine a typical passenger car traveling right up against its max possible speed in flagrant violation of the speed limit. It's going as fast as it can right up against the limits of its engine or governor. And just for fun, imagine that car is covered entirely in razor blades. That is the power of a table saw blade.